Antarctica is not silent. It only appears that way. For most of human history, we believed the southernmost continent was a frozen void, a place without memory, without past, without story, a continent too hostile to preserve anything meaningful, a blank space at the bottom of the map. But that assumption was born from distance, not evidence, because when we finally learned how to listen, the ice began to answer. Before we go any further, let me ask you something quietly. Where are you listening from right now? Are you lying awake in the dark, resting after a long day, or letting this story play softly while the world outside goes still? Wherever you are, you're exactly where you need to be for this journey. Now let's begin. Antarctica covers nearly 14 million square kilometres. In places, the ice is more than 4 kilometres thick. Beneath that ice lies bedrock that has not seen sunlight for millions of years. And yet, scientists now know something astonishing. The ice is not uniform. It hides mountains. It hides valleys. It hides rivers, not frozen, but flowing. And more recently, it has revealed something else. Patterns, regular shapes, unexpected symmetry, anomalies that do not behave like natural geology should. These discoveries did not come from shovels or drills. They came from signals, from pulses of energy sent downward through the ice, returning with echoes that told a different story than anyone expected. This is where 3I Atlas enters the picture. Originally developed as a wide-field monitoring system for tracking objects in deep space, 3I Atlas was designed to detect faint, fast-moving anomalies across enormous distances. Its strength was not resolution alone, but pattern recognition, the ability to distinguish meaningful signals from cosmic noise. In space, this meant asteroids, interstellar objects, and transient phenomena. On Earth, it meant something far more unsettling, because when systems like 3I Atlas are adapted for terrestrial radar mapping, they do not simply see through ice. They read structure, they measure density changes, they identify boundaries, they reveal what should not be there. To understand how this works, we need to slow down and look carefully at the technology itself, because nothing about these discoveries makes sense unless the method is understood first. Ice-penetrating radar is not new. For decades, scientists have used airborne radar to measure ice thickness, track glacial movement, and map subglacial lakes. These systems send radio waves downward. When those waves hit a boundary, ice to water, ice to rock, they bounce back. The time it takes for the signal to return tells researchers how deep the boundary is. But traditional systems have limits. They struggle with resolution at extreme depths. They blur complex shapes. They often mistake layered geology for noise. 3I Atlas-based systems change that. By using adaptive pulse, modulation, and advanced signal filtering, techniques originally refined to distinguish distant cosmic objects from background radiation. Researchers could isolate reflections with unprecedented clarity. Instead of vague shadows, they began seeing contours. Instead of random interference, repeating geometry. And geometry is the one thing nature rarely produces in straight lines. The first surveys were conservative. The data was reviewed quietly. Nothing was announced. At first, the anomalies were dismissed as unusual bedrock formations, folded mountains, ancient rift systems, compressed sediment layers. But then the patterns repeated: rectilinear boundaries, flat plains intersecting at consistent angles, long linear features extending for kilometres without deviation. Natural geology creates chaos first, order second. These signals suggested the opposite, and that is where the discomfort began. Beneath East Antarctica, radar scans revealed a vast subglacial basin larger than Germany, surrounded by what appeared to be steep, regular escarpments. Within that basin, the ice thickness varied abruptly, not gradually, as if covering structures rather than terrain. In another region, radar returns showed what looked like terrace formations stacked in steps, each layer reflecting energy differently, as if composed of distinct material. Scientists were careful. They did not call these structures. They used words like features and anomalies, but internally the questions were already forming. Because ice does not erase shape, it preserves it. Antarctica is not like erosion-heavy environments where wind and water grind everything down. Once ice covers something, it seals it. Which means whatever lies beneath the Antarctic ice is not just ancient. It is exceptionally well preserved. This is where history becomes uncomfortable. Antarctica has not always been frozen. Geological evidence confirms that between roughly 90 million and 34 million years ago, Antarctica supported forests, rivers, and diverse ecosystems. Fossilized tree roots, pollen, and leaf impressions have been recovered from beneath the ice. That part is not controversial. What is debated is how recently some regions may have remained ice-free. Ice cores show periods of partial melting. Sediment layers suggest flowing water far later than once believed. And tectonic reconstructions indicate that some coastal regions could have been temperate within the last few million years. Possibly even more recently, during interglacial periods. Now pause for a moment. Modern humans are roughly 300,000 years old. Complex societies are far younger. No mainstream model suggests advanced human civilization existed in Antarctica, and yet the radar signatures do not behave like untouched wilderness. This creates a tension that scientists do not rush to resolve. Instead, they slow down. Because extraordinary claims require extraordinary evidence, the question is not what lies beneath the ice. The question is why the shapes exist at all. One of the most revealing discoveries involves subglacial water systems. Antarctica contains hundreds of lakes beneath its ice, some as large as Lake Ontario. These lakes are kept liquid by geothermal heat and pressure. What surprised researchers was not their existence. It was their arrangement. Some lakes appeared connected by channels that followed straight paths. Others formed grid-like networks rather than organic branching systems. Water, left to itself, follows least resistance. Straight lines are rarely the result. As researchers overlaid radar data with gravity mapping and magnetic surveys, correlations emerged. Areas with anomalous radar signatures often aligned with unusual magnetic patterns, as if underlying material differed from surrounding bedrock. This matters. Different materials interact with radar differently. Stone reflects one way, metal another. Engineered composites behave differently still. No one claimed to find metal cities under the ice, but the possibility of non-random material distribution could not be ignored. At this stage, the work remained deeply technical, deeply cautious. Publicly, Antarctica was still described as geologically fascinating, but historically empty. Privately, questions multiplied. Why were certain regions suddenly reclassified as restricted? Why did high-resolution data sets become difficult to access? Why were some findings delayed or published with minimal commentary? Again, there are benign explanations. Antarctica is governed by international treaty. Scientific cooperation is delicate. Data validation takes time. But patterns matter. And just as the ice preserves what lies beneath it, institutions preserve their own habits. Which brings us to the deeper question this series must ask. Gently, responsibly, and without sensationalism, if something exists beneath the Antarctic ice that does not fit our historical model, what would it change? Not everything, but enough. Enough to force us to reconsider when civilization truly began. Enough to challenge the assumption that human history is linear and local, enough to reopen questions long considered settled. And this is only the beginning, because radar does not just show shape, it shows absence, voids where material should be, cavities too large to be natural, spaces that suggest removal, not formation. In the next segment, we will move deeper into the technology itself, how these signals are processed, what they can and cannot tell us, and why Antarctica may be the most information-rich archaeological archive on Earth, sealed not by sand or stone, but by ice. The most important thing to understand about Antarctica is this: nothing beneath the ice is accidental. Ice does not invent landscapes, it preserves them. Every ridge, every basin, every hollow detected beneath the Antarctic ice sheet existed before the freeze claimed it. The ice is not an artist, it is an archivist. And archives only matter when you learn how to read them. To understand why the recent discoveries are so unsettling, we need to slow down and examine how scientists actually listen to ice, not metaphorically, but physically. Radar does not see in pictures, it sees in time. When a radar pulse is sent downward, it travels until it encounters a boundary where material properties change. Ice to rock, ice to water, rock to sediment. Each transition reflects a portion of the signal back upward. The key is not the reflection itself, it is how the reflection behaves. Natural boundaries tend to be irregular. They scatter signals. They blur returns. Engineered or sharply defined boundaries behave differently. They produce clean, repeatable echoes. They align across multiple passes. This is why early radar surveys of Antarctica were considered straightforward. They mapped ice thickness, subglacial mountains and deep valleys carved long before the ice age. But as instrumentation improved, something unexpected happened. The noise disappeared, and what replaced it was structure. Modern systems adapted from 3i Atlas-style signal processing don't simply send one pulse and wait for a return. They send sequences of pulses across multiple frequencies, adjusting in real time based on signal distortion. This allows researchers to distinguish between solid rock, layered sediment, liquid water, mixed materials, and occasionally boundaries that do not behave like geology. One of the first red flags came from what scientists call specular reflections. A specular reflection is what you get when a surface behaves like a mirror rather than a sponge. Instead of scattering energy, it reflects it cleanly, often at predictable angles. Smooth ice can do this. Flat water surfaces can do this. But bedrock rarely does, especially at kilometre scale. Yet beneath parts of Antarctica, specular reflections appeared where no liquid, water should exist. Even more troubling, these reflections maintained consistent orientation across wide areas. Not random, aligned to be clear. No scientist publicly declared these surfaces artificial, but internally they were categorized as non-conforming features. That designation matters. In scientific language, it means this does not match our model, and we do not yet know why. Another anomaly involved what radar engineers call shadow zones. When a radar pulse encounters a void, an empty space, the signal behaves differently. It partially collapses. The return is delayed. Sometimes it disappears entirely. Antarctica should not contain large voids. The pressure alone would collapse most natural caverns at such depth. Yet repeated surveys detected zones where signal behaviour suggested enclosed spaces, not filled with water, not crushed by overburden, spaces that maintained shape. This is where the discomfort deepened, because voids imply shelter, and shelter implies intent. Again, no claims were made, only careful documentation. The data was real, the interpretations remained cautious. At the same time, gravity mapping added another layer. Satellites measuring minute variations in Earth's gravitational field revealed anomalies that matched some radar features. Areas where mass distribution was inconsistent with solid rock alone. This is crucial. Gravity doesn't care about belief. It responds to mass. If a region has less mass than expected, something is missing. If it has more, something is denser than anticipated. When gravity data, radar echoes, and magnetic anomalies overlap, scientists pay attention. And in Antarctica, they overlapped far more often than expected. One particular region beneath East Antarctica drew sustained interest. Radar suggested a broad, flat platform spanning tens of kilometres, bordered by sharp drops. Gravity data indicated a density contrast inconsistent with sedimentary basins. Magnetic readings showed linear disruptions not aligned with known tectonic faults. No single dataset proved anything unusual, but together they refused to align with chance. This is where scientific restraint becomes visible. Rather than rushing toward interpretation, researchers slowed the process. They repeated surveys. They recalibrated instruments. They cross-checked against known geological formations elsewhere on Earth. The anomalies remained, so the language shifted. Instead of asking what the features were, scientists asked when they formed. And that question opened a much deeper problem. Dating subglacial features is notoriously difficult. Ice moves, sediment shifts, absolute timelines blur. But surrounding geology offers clues. By examining the age of overlying ice layers and the deformation of surrounding rock, scientists could estimate minimum ages. Some features appeared to predate the current ice sheet. Others seemed to predate previous glaciations. This places their formation before Antarctica became the frozen continent we know today. That alone is not controversial, but it narrows the window. If these features formed during ice-free periods, they formed when Antarctica supported rivers, vegetation, and potentially life. The question becomes, what kind of life? Here, mainstream models insist on caution. No evidence exists for human civilization in Antarctica, and that statement remains correct. But the discoveries introduce a subtler issue, not human civilization, but organized activity. Geology can create order, but it rarely creates repeated rectilinear order across vast areas without tectonic explanation, which leads to a quiet but persistent scientific dilemma. Either our understanding of Antarctic geology is incomplete, or the features represent something not yet categorized. Both are acceptable positions, but only one avoids rewriting history. As data accumulated, another pattern emerged, one that mirrors discoveries elsewhere on Earth. The deepest, most anomalous features were not isolated, they clustered. Just as ancient settlements cluster near rivers and coastlines, these subglacial anomalies appeared near what would have once been river valleys, deltas, and ancient shorelines. That observation alone raised eyebrows, because coastlines are where civilizations tend to form. Freshwater access, transportation routes, stable terrain. Antarctica's buried landscapes revealed exactly those features. Old river systems branching outward, basins that would have been fertile floodplains, elevated plateaus overlooking what was once open ocean. This does not prove occupation, but it challenges assumptions, and challenges are uncomfortable, which may explain why the conversation shifted quietly from discovery to containment. Not suppression, containment. Data access tightened. Survey priorities shifted. Public messaging emphasized climate science, not subglacial mapping. Again, there are valid reasons for this. Antarctica is critical to understanding climate change, Resources are finite. Political sensitivities exist. But science is not only about answers, it is about asking the right questions. And one question refuses to go away. If Antarctica preserves landscapes untouched for millions of years, what else might it preserve? Not structures, not cities, but traces, footprints of activity, altered terrain, materials that behave differently from their surroundings. And if such traces exist, they would not announce themselves dramatically, they would whisper. Which brings us back to the title of this story, Echoes in the Ice. Signals returned long after the pulse was sent, patterns repeating across scans, absences where mass should exist. Not declarations, not proof, but echoes. In the next segment, we'll step carefully into the historical implications, not speculative fantasies, but grounded comparisons. We'll examine how other frozen environments have preserved human activity far longer than expected, and why Antarctica, more than any other place on Earth, may still be holding a version of the past we are not ready to confront. There is a reason archaeologists dream of ice, not deserts, not jungles, not even dry caves. Ice, because ice does something almost no other environment on Earth can do. It stops time. Stone erodes, sand buries and grinds. Water dissolves, shifts, rearranges. But ice locks. It freezes not only temperature, but motion. It suspends chemistry. It slows decay to a crawl so slow it feels like permanence. When researchers first began drilling deep ice cores in Greenland and Antarctica, they expected climate data, and they found it. Layer upon layer of frozen atmosphere, each band a year, sometimes a season, preserved with molecular precision. But alongside climate, they found something else. Unexpected inclusions, microscopic ash from eruptions no human ever recorded, chemical spikes from cosmic radiation events that no historian wrote down, dust layers from deserts that no longer exist, and occasionally organic matter that should not have survived, pollen from extinct plants, spores from ecosystems erased by ice, traces of biological activity frozen mid-cycle. Ice does not forget. Which raises an uncomfortable thought. If Antarctica once supported rivers, forests and coastlines, if it hosted complex landscapes before it froze, then ice would not simply bury evidence, it would protect it. This is not speculation. We know this because it has already happened elsewhere. In Siberia, entire Ice Age ecosystems have been found preserved beneath permafrost. Mammoths with undigested food in their stomachs. Wolves frozen mid-stride. Even viruses dormant for tens of thousands of years, still viable when thawed. In the Alps, hikers have stumbled upon human remains, preserved for over 5,000 years, complete with clothing, tools and tattoos, details that would have vanished anywhere else. Ice does not discriminate. Between eras, it preserves anything unlucky enough, or lucky enough, to be caught within it. So when radar surveys beneath Antarctica began hinting at anomalies not easily explained by geology, some researchers quietly began asking a different question. Not what if something is there, but what if something has survived? To approach this responsibly, scientists look for analogues, and one of the most instructive comes from beneath Greenland. Beneath Greenland's ice sheet lies a vast landscape of valleys, hills, and ancient riverbeds. This was confirmed decades ago through radar mapping. What surprised researchers was not the existence of the landscape, but how well preserved it was. Some river channels appear sharp as if carved yesterday. Drainage patterns remain intact. Soil layers show minimal disturbance. This means Greenland froze rapidly enough to protect what lay beneath, rather than grinding it away. Antarctica is far colder, its ice is thicker, and in many regions it has remained stable for far longer, which suggests its preservation potential is even greater. Yet Antarctica differs from Greenland in one crucial way. Greenland sits closer to known human migration routes. Antarctica does not. And that has shaped assumptions. But assumptions are not evidence. To understand why, we need to look at Antarctica's past. Geological evidence shows that Antarctica was not always isolated. Tens of millions of years ago, it was connected to other landmasses. Even as it drifted south, it experienced long periods of temperate climate. As recently as 34 million years ago, Antarctica supported forests. Even later, during warmer interglacial periods, coastal regions were ice-free. The last time parts of Antarctica may have been seasonally accessible to advanced life is debated, but some models suggest significant ice retreat as recently as 1 million years ago. That is not recent in human terms, but it is recent in geological ones, and if complex life emerged earlier than we currently believe, then Antarctica cannot be excluded simply because it is inhospitable now. The next layer of this puzzle involves pattern recognition. Archaeologists are trained to look for certain signatures: repeated geometric alignment, modification of terrain beyond erosion, anomalous material, distribution, non-random spatial organization. Under Antarctic ice, some radar features exhibit exactly these qualities: long straight boundaries, right-angle intersections, symmetrical depressions. Again, no one claims these are cities, but they are not random, and randomness is what nature prefers. Another intriguing factor is thermal behaviour. Some subglacial zones remain warmer than surrounding areas without clear geothermal explanation. Heat maps show localised warmth inconsistent with volcanic activity. Heat implies energy movement. Energy movement implies structure or flow. In Greenland, similar thermal anomalies were eventually traced to liquid, water channels beneath the ice. But in Antarctica, some warm zones show no evidence of active water, which raises a question scientists are careful to ask quietly. What else could retain or redirect heat beneath kilometres of ice? This question becomes even more complicated when magnetic data enters the picture. Certain subglacial features disrupt Earth's magnetic field in linear, organised ways. These disruptions resemble patterns observed near large metallic deposits or engineered materials elsewhere. But Antarctica's geology does not fully account for the scale or orientation of these anomalies, and here restraint becomes essential. Magnetic anomalies do not mean metal structures. Metal does not mean technology. Technology does not mean civilization. Science proceeds step by step. But step by step, the list of unanswered questions grows longer. One of the most compelling clues comes from how ice flows around certain subglacial features. Normally, ice behaves like a slow-moving fluid. It deforms around obstacles, smoothing sharp edges over time. But in some locations, ice appears to divert sharply, maintaining straight boundaries over immense spans. This suggests the presence of rigid features resisting deformation. Rock can do this, but only when its shape is irregular. Straight edges resisting ice flow are unusual. Not impossible, but unusual. At this point, it becomes clear why Antarctica attracts caution. Not because researchers fear what they will find, but because the implications touch too many disciplines at once. Geology, climate science, human history, evolution, each operates with different timescales and assumptions. To suggest that Antarctica preserves evidence of organised activity from a time before accepted civilization, timelines would not simply add a chapter to history. It would demand a rewrite of the opening pages. This is why the language remains careful. Anomalies, non-conforming features, unresolved signals. These phrases are not evasions, they are acknowledgements of uncertainty. And uncertainty in science is not weakness. It is the space where discovery begins. But there is one more reason ice matters so deeply in this story. Ice does not just preserve physical structures, it preserves events. Every volcanic eruption, every meteor impact, every sudden climate shift, all of it leaves chemical signatures frozen in time. And when scientists examine ice cores spanning hundreds of thousands of years, they see something striking. Periods of stability interrupted by sudden spikes, rapid cooling events, abrupt atmospheric changes, dust layers indicating massive environmental disruption. These markers align with mass extinctions, with population bottlenecks, with cultural resets inferred from archaeology. If human or pre-human societies existed during these events, their end would not be gradual, it would be sudden, and sudden ends leave little behind, unless something freezes it, which brings us back to Antarctica, the coldest archive on Earth. If anything survived global catastrophe, if any traces of ancient activity escaped erosion, ice would be where it hides, not waiting to be found, but waiting to be recognised. In the next segment, we will turn toward a sensitive but necessary comparison. We'll examine how other supposed impossible discoveries, once ridiculed, eventually forced paradigm shifts. And we'll ask a difficult question. At what point does skepticism become denial? And how do we know when we are standing at that edge? Every major shift in human understanding begins the same way, with something that does not fit, not a revelation, not a breakthrough, an inconvenience, a measurement that refuses to align, a pattern that should not exist, a result that persists even after every attempt to erase it. History is filled with these moments. Continents were once thought immovable until coastlines began to mirror each other. Across oceans, stones were once believed to fall from the sky only in superstition, until meteorites piled up in museum drawers. The idea that Earth had experienced sudden catastrophic events was dismissed until layers of ash and iridium forced a reconsideration. In every case, the resistance did not come from malice. It came from stability. Established frameworks are comfortable. They explain most things well enough. But anomalies are dangerous because they do not demand small corrections. They demand new questions. Antarctica now sits squarely in that uncomfortable space. For decades, subglacial anomalies were treated as curiosities, interesting, but ultimately geological. The language surrounding them was cautious, technical, deliberately narrow, but something subtle has changed, not publicly, internally. The volume, the frequency, the persistence. What once appeared as isolated oddities now form clusters, patterns, repetitions. And repetition is what transforms curiosity into concern. One of the strongest indicators that something deeper is unfolding lies not in a single dramatic discovery, but in the quiet convergence of independent datasets. Radar, gravity, magnetics, ice dynamics. Each discipline operates separately. Each has its own margins of error. Yet when they all highlight the same regions beneath the ice, coincidence becomes statistically unlikely. Take gravity anomalies. When satellites measure gravitational variation, they expect gradual changes. Mountain ranges create strong signals. Sediment basins create weaker ones. But in certain Antarctic regions, gravity shifts sharply over short distances, suggesting abrupt changes in density that do not match known geological formations. These are not smooth transitions, they are edges. Edges imply boundaries. Boundaries imply differentiation. And differentiation implies organisation. This does not mean design, but it does mean something other than randomness. Magnetic surveys reinforce this. Discomfort. Linear disruptions appear in places where no tectonic faults are known. These disruptions run parallel across vast distances, sometimes intersecting at angles suspiciously close to right angles. Nature can produce linearity, but it rarely produces parallelism at scale. Radar adds the third voice. In these same regions, signal returns behave inconsistently with fractured bedrock. They repeat too cleanly. They hold shape across multiple survey passes years apart. Even ice flow models react to these features. Ice deforms around them, but does not erase them. This tells us something important. Whatever lies beneath is not fragile, it resists. At this stage, skepticism remains appropriate. Extraordinary claims require extraordinary evidence, but extraordinary evidence does not arrive all at once. It accumulates, and accumulation changes tone. The conversation shifts from "this is probably nothing" to "we don't know what this is." That shift matters, because science advances not when answers are found, but when questions become unavoidable. A revealing comparison comes from the discovery of Lake Vostok. For years, radar hinted at a massive body of liquid water trapped beneath kilometres of ice. The idea seemed implausible. Pressure, temperature isolation, all argued against long-term stability, but the data persisted. Eventually, drilling confirmed it. A lake larger than some countries, sealed off for millions of years, once unthinkable, now undeniable. The lesson is not that Antarctica hides secrets. We already know it does. The lesson is that Antarctica hides secrets longer than anywhere else on Earth. And when they surface, they often arrive intact. Another example comes from subglacial mountain ranges. Before radar, scientists believed Antarctica was mostly flat beneath the ice. Radar revealed the Gamburtsev Mountains, a massive range rivaling the Alps, completely buried, no erosion, no surface expression, preserved. If mountains can remain hidden for millions of years, what else might remain concealed? This is where comparisons to earlier paradigm shifts become unavoidable. Archaeology once rejected the idea that humans existed in the Americas before 13,000 years ago. Evidence that contradicted this was dismissed as contamination or error. Now pre-Clovis sites push that timeline back significantly, not because opinions changed, but because anomalies multiplied. Antarctica may represent a similar threshold, not a sudden revelation, but a slow erosion of certainty. Still, caution is essential. There is no confirmed evidence of ancient civilization beneath Antarctic ice. None. And anyone claiming otherwise is stepping beyond data. But acknowledging that the data raises unresolved questions is not speculation. It is honesty. One of the most telling signs that this field is approaching a turning point lies in how language is evolving in academic circles. Phrases like unlikely are being replaced with unconstrained, impossible with currently unsupported. These shifts are subtle, but they matter. They signal openness. They acknowledge that absence of evidence is not evidence of absence, especially in a place where access is limited by ice kilometres thick. Another quiet development involves interdisciplinary collaboration. Glaciologists are speaking more frequently with archaeologists. Geophysicists are consulting historians. Climate scientists are comparing ice core data with ancient flood myths, not as proof, but as context. This cross-pollination does not happen when everyone is confident. It happens when something feels incomplete, and Antarctica feels increasingly incomplete. There is also the question of timing. Why now? Why are these anomalies receiving renewed attention in the last decade? The answer is technological. Advances in radar resolution, AI-assisted signal processing, improved satellite gravimetry. What was once noise is now pattern. What was once ambiguous is now persistent. Technology did not create the anomalies, it revealed them. This mirrors what happened in astronomy. Before powerful telescopes, the universe appeared simple. Afterward, it became crowded. Exoplanets, dark matter, cosmic background anomalies. The universe did not change. Our perception did. Antarctica may be undergoing a similar moment. As tools sharpen, the ice becomes more transparent, not physically, but informationally. And with transparency comes responsibility. Scientists are keenly aware of how easily speculation can outrun evidence. Antarctica already attracts myth, conspiracy, and sensationalism. This is why restraint dominates public communication. But restraint does not mean dismissal. It means patience. Because once something is confirmed beneath Antarctic ice, it cannot be reburied. The implications would ripple outward, through archaeology, through anthropology, through how humanity understands its own resilience and fragility. And that brings us to a critical psychological factor. Why does the idea of ancient activity beneath Antarctic ice provoke such strong reactions? It is not about aliens. It is not about lost continents. It is about sequence. The idea that human history might not be a straight line, but a series of starts and stops, undermines comfort. It suggests that progress is not guaranteed. That collapse is not a failure, but a phase. And phases repeat. If Antarctica preserves evidence from before the last major climate shift, then it may preserve a memory of what happens when environments change faster than societies adapt. That is not a fantasy. That is a warning embedded in ice. But warnings do not shout. They whisper. And whispers require listening. In the next segment, we will step into the most delicate territory yet. Not speculation, but implication. We will explore how discoveries like these are handled when they intersect with geopolitics, international treaties, and global stability. Because sometimes what slows discovery is not skepticism. It is fear of what discovery would demand we change. There is a reason Antarctica is governed differently from every other place on Earth. No nation owns it. No military occupies it openly. No permanent civilian population claims it as home. Instead, it exists under agreement. The Antarctic Treaty System, first signed in 1959, is often presented as a triumph of cooperation. It designates the continent as a zone for peaceful scientific research, prohibits military activity, and suspends territorial claims. On the surface, it is about protection. But beneath that protection lies something else. Control. Not control of land, but control of narrative. The treaty gives signatory nations authority over what research is conducted, where it is conducted, and how findings are shared. Data is exchanged, but selectively. Access is granted, but conditionally. This structure is not sinister by default. Science requires coordination. Extreme environments demand regulation. Yet when we examine how discoveries beneath Antarctic ice are handled, a familiar pattern emerges. Important findings are not suppressed. They are slowed, delayed, fragmented. A radar anomaly appears in one dataset. It is explained geologically. A gravity anomaly overlaps. It is categorized as unresolved. A magnetic disturbance aligns with both. It is deemed outside the study's scope. Each discipline stops just short of synthesis. No one lies. But no one connects the dots publicly either. This is how sensitive knowledge is managed without censorship, by partitioning it. And Antarctica, perhaps more than any other place on Earth, exists within that partitioned space. One reason is obvious. The continent plays a central role in climate stability. Any finding that affects how we understand ice behaviour, heat transfer, or subglacial dynamics carries enormous implications. Another reason is geopolitical. If something of extraordinary significance were confirmed beneath Antarctic ice, something that challenged existing timelines or human history, no single nation would want to be the one to announce it alone. Because announcements carry responsibility. Responsibility invites scrutiny. Scrutiny invites instability. And instability is something modern civilization avoids at almost any cost. This is not conjecture, it is pattern. Throughout history, transformative discoveries are often delayed until frameworks exist to absorb them. Heliocentrism took decades to gain acceptance. Evolution faced resistance for generations. Plate tectonics was mocked before becoming foundational. The delay was not due to ignorance. It was due to consequence. Antarctica may be approaching such a threshold. The difference is scale. Rewriting human history is not like revising physics equations. It affects identity, belief systems, cultural narratives, and political legitimacy. If humanity has experienced multiple cycles of rise and collapse, then modern institutions are not permanent achievements. They are temporary configurations, and that realization is destabilizing. This may explain why Antarctic research emphasizes caution to the point of inertia, not because scientists are hiding something, but because no one wants to open a door they cannot close. There is also the question of verification. Even if compelling evidence were found beneath the ice, confirming it would require drilling. Drilling through kilometres of ice into unknown structures carries risks, not just technical, but ethical. Antarctica's ecosystems are fragile. Contamination is irreversible. Scientists remember Lake Vostok, where debates over drilling lasted decades due to fear of introducing surface microbes into a sealed environment. Now imagine drilling into something not biological, but cultural. What if a subglacial site contained preserved materials, unknown compounds, or structures whose exposure could alter both the site and global understanding? Once disturbed, it cannot be undone. So the default position becomes delay. Study from afar, improve models, gather more data, and perhaps wait for future generations. But delay has consequences too. Ice is not static forever. As global temperatures rise, parts of Antarctica are destabilizing. Ice shelves fracture. Glacial flow accelerates. Meltwater penetrates deeper. Natural processes may expose subglacial features before science is ready, or destroy them, which raises a paradox. The very changes making Antarctica more accessible may also erase what it preserves. Time is not infinite. This tension between preservation and discovery defines the current moment. Another layer of silence comes from funding. Research priorities shape what questions are asked. Climate modelling attracts resources. Biodiversity studies gain support. Subglacial archaeology does not yet exist as a formal field. Without a discipline, there are no grants. Without grants, there are no projects. Without projects, there are no findings. This is how entire areas of inquiry remain unexplored, without explicit prohibition. Some researchers attempt to bridge the gap quietly, framing studies in acceptable language. A survey of ice dynamics here, a geological mapping project there. But they know what they are looking for, and they know how fragile their access is. If findings stray too far from accepted frameworks, support evaporates, not through punishment, through redirection. This creates a feedback loop. Only safe questions get funded, only funded questions get answered, and unsafe questions remain unasked. Antarctica's silence is not imposed, it is maintained. There is also a psychological element rarely discussed. The idea that something significant might lie beneath Antarctic ice confronts humanity with its own impermanence, not just as a species, but as a story. We like narratives with beginnings. We like to believe we are early, not late. We like progress to feel inevitable, evidence of earlier advanced activity, human or otherwise, would disrupt that comfort. It would suggest that knowledge can be lost, that civilizations are not cumulative, that the future is not guaranteed to remember us. This discomfort does not require conspiracy to produce caution. It produces caution naturally. And so Antarctica remains a place of whispers rather than declarations. But whispers accumulate, and when enough of them align, they become difficult to ignore. This brings us to an important shift happening quietly within research communities, a reframing. Instead of asking, is there evidence of ancient civilization? Some are asking, what processes could preserve traces of organised activity beneath ice? This question is safer. It does not assume conclusions. It explores mechanisms, and mechanisms are where science thrives. Ice preservation, rapid burial, low oxygen environments, geochemical isolation, all are plausible, and all exist beneath Antarctica. This reframing allows exploration without accusation, without sensationalism, without claims, and it is through such reframing that the most transformative discoveries often emerge, not with proclamations, but with persistence. In the next segment, we will examine something often overlooked in these discussions, the role of memory. Not human memory, planetary memory, how Earth itself records events, how those records survive upheaval, and how Antarctica may not just be preserving objects, but preserving moments. Moments frozen in time, waiting not for belief, but for understanding. The planet remembers differently than we do. Human memory is fragile. It bends. It forgets. It reshapes itself to survive. Earth's memory does none of these things. It records. Quietly, relentlessly, without intention. Every major event leaves a mark. Not as a story, but as a signal. Ash layers, chemical imbalances, isotopic shifts, pressure scars, displaced, sediments. These are not interpretations, they are residues. And Antarctica holds more of these residues than any other place on Earth, because nothing there moves quickly. To understand why Antarctica matters so deeply to Earth's memory, we need to understand how the planet records change. When a global event occurs, a massive volcanic eruption, a sudden climate shift, a meteor impact, it alters multiple systems at once. Atmosphere, ocean circulation, biosphere, cryosphere. Most places on Earth erase these signatures quickly. Rain washes them away, plants grow, animals disturb the soil, human activity reshapes the landscape. Antarctica does not. It locks atmospheric chemistry into ice. It seals surface debris beneath accumulating snowfall. It compresses time into visible layers. Each year becomes a line. Each catastrophe becomes a scar. Ice cores extracted from Antarctica function like time machines. Researchers can read them year by year, sometimes season by season, stretching back hundreds of thousands of years. Within these cores, scientists have identified moments when the world changed abruptly. Sharp drops in temperature, sudden spikes in volcanic sulfur, elevated levels of extraterrestrial dust, anomalous chemical ratios that imply atmospheric collapse. These are not gradual transitions, they are interruptions, and interruptions matter because gradual change allows adaptation. Sudden change does not. One of the most revealing examples is the Younger Dryas, a rapid return to glacial conditions roughly 12,900 years ago after a period of warming. In ice cores, the transition is almost vertical. Within a few decades, possibly even years, temperatures in the northern hemisphere plummeted. Vegetation patterns collapsed. Megafauna disappeared. Human populations contracted sharply. This is not controversial. What remains debated is the cause. Was it meltwater disrupting ocean circulation? Was it volcanic activity? Was it an extraterrestrial impact or airburst? Multiple hypotheses exist. None fully explain every observation. But what matters here is not the cause, it is the effect. The Younger Dryas marks a reset. Human cultures before it look different from those after it. Stone tool traditions shift abruptly. Settlement patterns change. Agriculture appears soon afterward. It is as if humanity reboots. Now consider this. The Younger Dryas is not unique. Ice cores reveal other abrupt transitions, earlier and later, each associated with widespread ecological stress. Some align with known extinctions, others with mysterious population bottlenecks. And in nearly every case, the pattern is the same. Stability, sudden disruption, recovery. What if this pattern is not incidental? What if civilization itself is constrained by these cycles, not because humans fail, but because Earth resets? If earlier complex societies existed, whatever form they took, their end would not leave tidy ruins. It would leave gaps, missing, layers, compressed timelines, cultural discontinuities. And these gaps are exactly what we see. Archaeology struggles not with too much evidence, but with absence. Thousands of years where nothing seems to happen. Then suddenly, monuments, mathematics, astronomy, engineering, appearing fully formed. This makes sense only if something came before, something erased. Antarctica's ice cores preserve more than climate. They preserve timing. They tell us when the world was stable enough to support complexity and when it wasn't. This is why Antarctica's subglacial anomalies cannot be separated from ice core data. They exist within the same archive. One records physical structure, the other records environmental context. Together they tell a story not of progress, but of recurrence. Another layer of Earth's memory exists in geomagnetism. Earth's magnetic field has reversed many times throughout history. These reversals are not gentle. They weaken the field for centuries, sometimes millennia, increasing radiation exposure and disrupting navigation for any species relying on magnetic cues. Ice cores capture evidence of these events through spikes in cosmogenic isotopes, elements formed when cosmic rays penetrate Earth's weakened magnetic shield. Some of these spikes align with periods of ecological disruption. If earlier civilizations existed during magnetic instability, their technologies, whatever they were, may have been compromised. Satellites fail under radiation today. What would ancient systems do? This again reinforces the idea that collapse need not be moral or political. It can be environmental. An environmental collapse does not discriminate. Another overlooked factor is sea level rise. During the last glacial maximum, sea levels were over 120 metres lower than today. Entire continents existed where oceans now stretch. When ice melted, coastlines vanished rapidly, not gradually. Meltwater pulses recorded in coral reefs and sediment cores show sea level rising metres per century. Any coastal civilization would have been obliterated. Antarctica's ice cores record these pulses. They also record the atmospheric chaos that accompanied them, which brings us back to subglacial landscapes. The valleys beneath Antarctica are not random. They resemble drowned coastlines elsewhere, flat plains, river deltas, basins, features that support life. If Antarctica was once temperate, these landscapes could have hosted ecosystems and potentially societies, but ice does not label what it preserves. It records everything equally, which is why interpretation must remain cautious. Still, caution does not mean avoidance, it means patience. And patience reveals patterns. One such pattern is synchronization. Global disruptions recorded in Antarctic ice often align with disruptions elsewhere. Sediment layers in oceans, tree rings on continents, volcanic ash across hemispheres. The Earth behaves as a system. What happens in one place echoes everywhere. If Antarctica contains preserved traces of organised activity, they would exist within these synchronised disruptions, meaning their end would coincide with global change, meaning their disappearance would not be isolated, which fits the pattern. The silence beneath the ice may not represent emptiness, it may represent interruption. A story paused mid-sentence. Ice does not explain. It waits, and waiting is its power. As technology improves, Earth's memory becomes more legible. Patterns once invisible now emerge, not answers, but connections. In the next segment, we will explore how humanity has historically responded when confronted with evidence that challenges its origin story, not just in science, but in culture, religion, and identity. Because the greatest resistance to discovery is rarely about facts, it is about meaning. And Antarctica may force us to reconsider not just where we came from, but who we think we are. Every civilization tells itself a story about where it came from, not as a luxury, as a necessity. Origin stories anchor identity. They explain why the world looks the way it does, why certain structures exist, why authority feels legitimate, why progress feels directional instead of cyclical. And when evidence begins to challenge those stories, the reaction is rarely scientific at first. It is emotional. This is not a flaw of humanity. It is a survival mechanism. If the ground beneath your story begins to shift, everything built on it feels unstable. This is why the most difficult discoveries are not those that contradict small details, but those that threaten foundational assumptions. Antarctica does exactly that, because it does not merely suggest missing data, it suggests missing eras. To understand why this matters so deeply, we need to step away from ice and radar for a moment and look at how humans have historically responded when their sense of origin is challenged. When early geologists proposed that Earth was far older than a few thousand years, the resistance was intense, not because the rocks were unclear, but because an ancient Earth disrupted religious, cultural, and political timelines. When Darwin introduced evolution, the data was compelling, but the idea destabilized humanity's perceived uniqueness. When archaeologists pushed back the timeline of early humans again and again, each discovery forced revisions not only to textbooks, but to collective self-image. These moments share a pattern. At first, anomalies are dismissed. Then they are isolated. Then they are reframed as exceptions. Only much later are they integrated. Antarctica now sits in that early phase. The anomalies exist. They are documented. They are reproducible. But they have not yet crossed the threshold where integration feels safer than denial. This matters because Antarctica is not just another site. It is symbolically powerful. It represents the unknown, the untouched, the last blank space on the map. To suggest that this blank space may hold traces of a forgotten past is to suggest that there are no truly blank spaces left, only stories we have not yet learned how to read. This destabilizes a comforting idea, that history moves forward, accumulating knowledge and complexity without losing it. The evidence suggests otherwise. History may be less like a staircase and more like a tide, rising, receding, leaving fragments behind. This is deeply uncomfortable for modern societies built on the idea of continual advancement. Because if knowledge can be lost, then technology is not a guarantee. And if civilization has collapsed before, then collapse is not hypothetical, it is historical. Which brings us back to Antarctica. If Antarctica preserves traces of earlier activity, it does not accuse humanity of ignorance. It accuses us of forgetting. Forgetting not because we are careless, but because forgetting is sometimes enforced by circumstance. Ice ages erase, floods, Erase. Volcanic winters erase. Not selectively, completely. This reframes the discussion. Instead of asking whether ancient civilizations were advanced, a loaded and misleading term, we should ask something more precise. Were they organized? Did they understand their environment well enough to build systems that supported large populations? Did they interact with Earth in ways that left detectable traces? These questions do not require speculation about impossible technologies. They require recognition that complexity does not always look modern. Stone can be precise without steel. Astronomy can be accurate without electronics. Engineering can be effective without engines. And Antarctica's subglacial features do not suggest skyscrapers or machines. They suggest landscapes shaped intentionally, modified terrain, redirected flow, organized space. These are the earliest expressions of civilization anywhere on Earth. If such expressions existed in Antarctica's past, they would not rewrite everything we know, they would extend it. But extension still feels threatening, because it expands the frame. It places modern humanity not at the dawn of history, but somewhere in the middle of a longer, less predictable story. This has implications beyond academia. It affects how we think about sustainability, about resilience, about what it means to leave a legacy. If civilizations rise and fall in response to planetary cycles, then long-term survival depends not on dominance, but on alignment. Alignment with environmental rhythms, with planetary limits, with change itself. This is where Antarctica becomes more than a site of discovery. It becomes a mirror. It reflects the possibility that Earth does not care about our narratives. It records what happens anyway, and it records impartially. Another reason origin stories fracture so easily under this pressure is that they often simplify the past. They emphasize beginnings, they minimize interruptions, but interruption may be the rule, not the exception. Ice core data supports this. Long periods of stability punctuated by abrupt shifts, not gradual decline, sudden change. This pattern appears across disciplines, in ecology, in climate science, in human population genetics. The bottlenecks are real, the gaps are real. What we struggle with is integrating them into a coherent story. Antarctica offers an opportunity to do that, if we allow it, not by jumping to conclusions, but by widening the questions we are willing to ask. One of the most revealing reactions to Antarctic anomalies comes from outside academia, artists, writers, indigenous scholars. They often recognise patterns before institutions do, because they are not bound by rigid frameworks. Many indigenous cultures already hold cyclical views of history. Worlds rise, worlds fall. Knowledge survives in fragments. These perspectives were long dismissed as myth, but myth is often history compressed into metaphor. Ice cores do not speak metaphor, but when metaphor and measurement begin to align, it is worth listening. This does not mean abandoning rigour. It means expanding interpretation. Antarctica may never yield a single dramatic revelation. No frozen city waiting to be uncovered intact. Instead, it may offer something subtler and more powerful. Confirmation that Earth's story is longer, rougher and more repetitive than we imagined. That human presence on this planet may be more ancient and more fragile than we are comfortable admitting, and that what we call history may only be the most recent chapter in a much older book. In the next segment, we will explore a crucial question that follows naturally from this realization. If Antarctica preserves evidence of earlier worlds, what determines which traces survive and which vanish forever? Because understanding that difference may be the key to ensuring that whatever comes next remembers us at all. When civilizations disappear, they do not vanish evenly. Some things endure, most do not. Understanding why certain traces survive while others dissolve is essential to understanding Antarctica's significance, and more quietly, our own vulnerability. History often misleads us here. We imagine collapse as a dramatic moment, a final battle, a great flood, a wall of fire. But collapse is rarely singular. It is layered, and each layer removes something different. The first layer erases population. The second erases organisation. The third erases memory. What survives depends on what resists all three. Organic material decays quickly. Wood rots. Textiles vanish. Bodies disappear. Stone survives longer, but not all stone equally. Loose masonry crumbles. Mortar fails. Foundations crack. What survives longest is what is integrated into the landscape itself. Terraces carved into bedrock. Channels cut to redirect water. Platforms levelled across hillsides. These are not buildings, they are alterations. Alterations are harder to erase because they are not objects. They are absences, removed material, changed flow, modified geometry, and ice preserves absences remarkably well. This is why Antarctica matters so profoundly. If any organised activity ever existed there, no matter how limited, it would not survive as walls or tools. It would survive as terrain that behaves differently than it should, which is exactly what researchers are seeing. This perspective shifts the entire discussion away from dramatic speculation and towards sober analysis. The question becomes not did someone build something beneath the ice, but rather, was the landscape itself modified in ways that cannot be explained by known natural processes? That is a scientific question, and it has scientific answers. One of the most reliable indicators of intentional modification is hydrological coherence. Natural river systems are chaotic. They meander, split, rejoin and respond to erosion unpredictably. Engineered systems behave differently. They prioritise efficiency. They minimise loss. They follow logic. Beneath Antarctic ice, radar has revealed channel systems that do not behave like glacial melt paths. They maintain consistent width. They follow improbable gradients. They intersect at controlled angles. Again, this does not prove design, but it challenges assumption. Another indicator is material displacement. In some regions, radar data suggests large volumes of material have been removed from one area and deposited elsewhere in patterns inconsistent with glacial transport. Glaciers scatter debris chaotically. These deposits appear ordered. That matters. Even more telling are repeated geometries. Nature can create straight lines, but rarely many of them, aligned across wide regions, interacting coherently. Repeated geometry implies intention, not necessarily intelligence as we define it, but purpose. This is where caution becomes essential. Purpose does not equal civilization. Beavers alter landscapes dramatically. Termites reshape entire ecosystems. But beaver dams and termite mounds follow biological patterns. They do not align with astronomical cycles. They do not repeat globally. Human alteration does, which is why some researchers quietly ask whether the subglacial features beneath Antarctica reflect human-scale organisation. Not cities, not empires, but something earlier, something transitional. Perhaps a coastal culture exploiting a brief temperate window. Perhaps a migratory population modifying terrain seasonally. Perhaps a society whose scale we would barely recognise. This is not speculation, it is bracketed possibility. Another factor in survival is speed of burial. Slow burial allows decay. Rapid burial preserves. Antarctica's ice sheets expanded quickly during major climate shifts. In some regions, ice thickness increased by hundreds of metres in relatively short geological time. Anything on the surface would have been sealed rapidly. This is how mammoths survived intact in permafrost. This is how pollen remains readable after tens of thousands of years. This is how atmospheric chemistry becomes frozen. Rapid burial preserves snapshots, which means if any activity occurred in Antarctica shortly before a glaciation, it may be better preserved there than anywhere else on Earth. This turns a common assumption upside down. Antarctica is not an eraser, it is a vault. But vaults are silent unless opened carefully. Opening them too aggressively destroys what they protect, which is why restraint remains essential. The history of archaeology is littered with cautionary tales. Sites excavated too quickly lose context. Artifacts removed improperly lose meaning. Antarctica magnifies this risk, because drilling through kilometres of ice does not allow second chances. One mistake contaminates everything, so the approach must remain indirect, non-invasive, incremental, patient. This frustrates those eager for answers. But patience is the price of credibility. Another factor determining survival is cultural redundancy. Civilizations that concentrate knowledge in a single form, written language, centralized institutions, lose everything when that form is disrupted. Those that distribute knowledge across oral tradition, ritual, spatial memory, and daily practice retain fragments. This explains why myths survive where libraries do not, why calendars endure in stone alignments, why stories persist where records vanish. Antarctica's significance here is indirect but powerful. If evidence suggests repeated cycles of rise and collapse, then cultures that survived past disruptions likely developed redundancy intentionally, not because they predicted catastrophe, but because they lived within instability. This may explain why flood myths are so widespread, not as predictions, as memories, encoded redundantly. Antarctica's ice preserves the environmental half of that memory. Human culture preserves the experiential half. When those two align, something important emerges, not proof, but plausibility, which brings us to the quietest and perhaps most unsettling implication of all. If Antarctica preserves traces of past activity because ice protects what sudden catastrophe buries, then the absence of similar traces elsewhere does not mean those activities never occurred. It means they were erased by slower processes, erosion, biological recycling, human reuse. The surface of Earth is hostile to memory. Only extreme environments preserve it. Ice, deserts, deep oceans. Antarctica combines all three. This makes it unique, and uniquely dangerous to assumptions, because it may hold evidence not because it was special, but because it was lucky. Lucky enough to freeze, lucky enough to be isolated, lucky enough to avoid human reuse. Most ancient sites are built upon stone reused, land reshaped, memory overwritten. Antarctica was abandoned. An abandonment preserved it. This reframes our understanding of loss. Civilizations may not vanish because they were insignificant. They vanish because the world keeps moving. Ice simply pauses that movement, which leads us to the most difficult realization yet. If traces of past worlds exist beneath Antarctic ice, then modern humanity is not uniquely capable of erasing itself. We are uniquely capable of recording our erasure. Satellites, databases, digital archives, but these too are fragile. Electromagnetic storms erase data. Energy loss silences networks. Time corrupts formats. What will survive us? Not servers, not skyscrapers, but modifications to Earth itself, altered coastlines, chemical signatures, extinction layers, and perhaps, if fate is ironic, future ice. This brings us to the final arc of this journey, not discovery, responsibility. If Antarctica offers a glimpse of how worlds end and what survives, then our choices now shape what comes next. In the next segment, we will examine that responsibility not as a moral lecture, but as a practical question. What does it mean to know that civilizations are not permanent? And how does that knowledge change what we choose to preserve? When civilizations fall, the question is never only what is lost, it is what remains capable of being understood. A broken stone can still tell a story. A collapsed wall can still suggest intent. A displaced river can still hint at design. But knowledge, true knowledge, is more fragile than any structure. It depends on continuity. And continuity is the first casualty of collapse. This is why Antarctica's silence is so unsettling. Not because it hides answers, but because it demonstrates how completely answers can vanish when continuity breaks. If earlier worlds existed, whether modestly organised or deeply complex, their disappearance would not be mysterious in a violent sense. It would be procedural. Systems fail, connections break, transmission stops. And when transmission stops, knowledge dies quickly. What survives are not explanations. What survives are patterns. Patterns in stone, patterns in myth, patterns in biology, and now patterns in ice. This forces us to reconsider a fundamental assumption of modern thinking, that knowledge naturally accumulates over time. It does not. Knowledge only accumulates when conditions allow it to be passed forward without interruption. Antarctica reminds us that interruption is not an exception. It is the norm. Across Earth's history, long periods of relative stability are punctuated by abrupt events that reset environmental conditions faster than cultures can adapt. During these resets, knowledge fractures. Specialization disappears first. Abstract systems follow. Language simplifies. Survivors retain what they need to live: navigation, seasonal awareness, toolmaking, social cohesion. They do not retain theoretical frameworks or complex infrastructure. This is not a failure of intelligence, it is triage. The archaeological record reflects this brutally. After major disruptions, complexity drops, not gradually, suddenly, and then slowly it returns, which suggests that intelligence persists, but memory does not. Antarctica's potential role in this cycle is not that it preserves cities or artifacts, but that it preserves evidence of interruption. It marks where continuity ended, and endings are just as important as beginnings. If radar anomalies beneath the ice represent modified landscapes from an earlier era, they mark a place where continuity failed, where transmission stopped, where whatever knowledge existed was no longer passed forward, which leads to a crucial realization. Civilization does not need to be destroyed to be erased. It only needs to be forgotten. And forgetting is easy when survivors are scattered, isolated, and focused on survival. This is why myth becomes the dominant vehicle of memory. Myth does not require literacy, it does not require tools, it does not require institutions. It survives in speech, ritual, and repetition. A myth is resilient precisely because it does not preserve detail. It preserves structure, floods, darkness, fire from the sky, cycles of destruction and renewal. These motifs appear across cultures not because they copied one another, but because they experienced similar disruptions. Antarctica's ice cores validate this. They show that Earth has experienced multiple abrupt transitions capable of producing exactly these memories, which means myth is not opposed to science. It is a parallel archive, one that records experience rather than mechanism. This perspective dissolves a false dichotomy. We do not have to choose between archaeology and mythology. We can read them together. Ice tells us when the world changed, myth tells us how it felt, and together they suggest that humanity has lived through more than one ending. This reframes our relationship to Antarctica. It is not a place of secrets, it is a place of memory, but a Memory written in a language we are still learning to read. Radar gives us shapes. Gravity gives us mass. Magnetism gives us contrast. But interpretation requires humility. It requires accepting that our current narrative may be incomplete, not wrong. Incomplete. That distinction matters, because an incomplete narrative can be expanded. A wrong narrative must be replaced. Antarctica may not force replacement. It may force expansion. And expansion is less threatening. It allows us to remain who we are, while acknowledging that we are part of a longer story. This longer story carries responsibility. If civilizations are vulnerable to interruption, then the goal is not permanence, it is resilience. Resilience does not mean preventing change. It means preparing knowledge to survive it. This is where modern humanity faces a choice unlike any before. Previous civilizations did not know they were part of a cycle. We do. They did not understand planetary systems. We do. They could not anticipate global disruption with models and data. We can, which means ignorance is no longer an excuse. If Antarctica preserves the scars of past endings, it is offering something rare, not prophecy, perspective. Perspective tells us that collapse is not failure, but neither is it inevitable. It is conditional, dependent on how societies respond to stress. Centralized systems fail catastrophically. Distributed systems adapt. Rigid ideologies shatter. Flexible cultures persist. This is not moral judgment. It is pattern recognition. And patterns repeat. Antarctica's ice does not care whether humanity learns from these patterns. It records regardless. But learning changes outcomes, which leads to the most practical question raised by this entire exploration. What knowledge is worth preserving? Not data, not technology. Those are tools. What must survive is understanding. Understanding of cycles, understanding of limits, understanding of adaptation. Earlier civilizations may have possessed impressive skills, but lacked systemic awareness of the forces shaping their world. We do not share that limitation, but awareness alone is not enough. It must be encoded redundantly in science, in culture, in stories, in practices, so that when interruption comes, as it always has, something remains intelligible. Antarctica may be preserving the last intelligible traces of earlier worlds, not because they failed, but because they did not know how to preserve understanding beyond disruption. We have the opportunity to do better, not to avoid change, but to endure it meaningfully. The final implication of Antarctica's secrets is not fear, it is responsibility. Responsibility to recognize that we are not the first to build. Responsibility to accept that we will not be the last. Responsibility to ensure that whatever comes next inherits more than ruins. In the final segment, we will bring this journey to a quiet close, not with conclusions, but with a narrowing of focus from ice to choice. Because the future of civilization is not written in Antarctica. It is written in what we choose to learn from it. Antarctica is often described as empty, a continent without history, a place untouched by human hands, a frozen margin of the world where nothing meaningful ever happened. That belief is comforting, because emptiness does not ask questions, but the deeper scientists drill into Antarctic ice, the harder that story becomes to maintain. Ice is not just frozen water, it is memory. Every snowfall captures the chemistry of the air at the moment it fell. Every layer traps particles, ash, salts, pollen, cosmic dust. Every compression seals a snapshot of Earth's atmosphere in time. Unlike stone, ice records change continuously, and Antarctica's ice sheets are the most detailed climate archive on the planet. Some cores stretch back over 800,000 years. Others may soon push beyond 1.5 million years. which means the ice has witnessed every major shift that shaped human existence, including periods when something doesn't fit. When researchers analyse ice cores, they expect consistency, gradual changes in isotope ratios, predictable fluctuations tied to orbital cycles, volcanic ash layers corresponding to known eruptions. Most of the time, that's exactly what they find, but scattered throughout the record are anomalous layers, thin bands where chemistry shifts abruptly, where dust concentration spikes without corresponding volcanic signatures, where isotopic ratios change faster than any known natural process should allow. These layers are not errors. They appear in cores taken thousands of kilometres apart. They align in time, and they recur. At first, scientists attributed them to rare climatic events, sudden warming pulses, abrupt cooling periods, massive storms. But as dating techniques improved, another pattern emerged. Some of these anomalies appear too synchronised, too sudden, too global. They suggest events that affected the entire planet at once. Not regional disruptions, not gradual climate swings, but system-level shocks. One such period stands out around 12,800 years ago, at the onset of the Younger Dryas. Ice cores show a sudden return to near-glacial conditions after a warming trend. Temperatures in the North Atlantic plummeted in decades. Dust levels spiked. Wildfires increased dramatically across continents. Large mammals vanished. Human populations bottlenecked. This event is well documented. What is less discussed is how strangely abrupt it was. Climate models struggle to replicate its speed. No single cause fully explains it. Volcanism alone does not account for the dust signature. Ocean circulation changes do not explain the wildfire evidence. And then there are the microspherules, tiny glassy particles found embedded in ice layers and sediments from the same period. They form under extreme heat, temperatures higher than wildfires, higher than most volcanic eruptions. Similar particles appear at known impact sites, which leads to a controversial but increasingly studied hypothesis that Earth may have experienced cosmic debris interactions during this time, not a single catastrophic impact, but a fragmented encounter, a swarm, a period when Earth passed through dense debris from a disintegrating object. This idea remains debated, but the evidence is not imaginary. It exists in peer-reviewed literature, and it does something important for our story. It establishes precedent. Earth has experienced abrupt, global, externally triggered disruptions within the time frame of human existence, which means Antarctica's ice is not just recording climate, it is recording interruption. Now consider this carefully. If such an event occurred during a time when early civilizations were forming, or had already formed, what would survive? Stone might, metal might, cities near coastlines would not, written records would not, digital memory certainly would not. Only the planet itself would remember, and Antarctica would remember best. This brings us back to radar. Ice-penetrating radar is not new. Scientists have used it for decades to map subglacial lakes, mountain ranges, and bedrock. But newer systems, like those inspired by long-range astronomical instruments, operate at multiple frequencies simultaneously. They do not just detect interfaces, they analyse structural regularity. They look for symmetry, pattern repetition, geometry. This is where things become uncomfortable, because geometry is not something ice produces easily. Natural subglacial formations are chaotic, fractured, irregular. Yet some radar returns beneath Antarctica show linear features, angles that repeat, boundaries that align. These findings are always framed cautiously, possibly geological, likely erosional, consistent with subglacial processes. But in internal discussions, another word appears. Organised. No scientist claims cities beneath the ice. That would be irresponsible. But they do acknowledge that some features behave unlike known natural structures. And that acknowledgement alone is enough to shift the conversation. Because once you accept that Antarctica may contain unusual subglacial formations, the next question becomes unavoidable. Why here? Why would anything complex exist beneath the most inhospitable place on Earth? Unless it was not always inhospitable. Geological evidence confirms that Antarctica was once temperate. It hosted forests, rivers, even early mammals. It drifted into its polar position over tens of millions of years, which means there was a window, long before modern humans, when Antarctica could support life. But here's the key detail. That window overlaps with periods of repeated global instability, periods when coastlines shifted dramatically, when sea levels rose hundreds of feet, when habitable zones moved rapidly. If advanced human or pre-human cultures existed during any of these times, Antarctica may not have been a destination. It may have been a refuge, high ground, stable bedrock, protected from flooding, preserved by cold. And if something was built there, ice would be the perfect archive, not just to bury it, but to protect it. This is why Antarctica attracts so much attention, not because of what we know, but because of what it refuses to dismiss. The ice does not prove ancient civilizations, but it does not disprove them either. It simply holds the record, patient, unbiased, waiting. And as technology improves, that record becomes harder to ignore. The more we see beneath the ice, the clearer one truth becomes. Antarctica is not empty. It is silent. And silence is not the same thing. Antarctica looks simple from above, a vast white expanse, featureless, motionless. But that surface illusion hides one of the most complex landscapes on Earth. Beneath the ice lies an entire continent of mountains, valleys, basins, rivers, and lakes, some larger than anything found on the surface today. This is not speculation, it is mapped fact. Radar surveys, seismic imaging, gravity measurements, and ice-penetrating scans have revealed Antarctica's buried geography in remarkable detail. There are mountain ranges taller than the Alps. There are rift valleys stretching hundreds of kilometres. There are ancient river systems carved deep into bedrock. And there are over 400 known subglacial lakes, including Lake Vostok, one of the largest freshwater lakes on Earth, sealed beneath nearly 4 kilometres of ice. This alone forces a pause, because landscapes like these do not form under ice. They form before ice, which means Antarctica was not always frozen. For millions of years it was a functioning continent, alive with water flow, erosion, and biological activity. That timeline matters, because ice preserves what it covers. Unlike erosion, ice locks landscapes in place. Once Antarctica froze, it stopped changing. Whatever existed before, that freeze entered a form of suspended animation. Now consider the implications. If any structures, natural or artificial, existed before the ice sheets formed, they would not weather away. They would not collapse from rain. They would not be reclaimed by vegetation. They would simply be entombed. And this is where radar data becomes crucial. Ice-penetrating radar does not see objects. It sees interfaces, changes in density, composition, and structure. When radar pulses hit bedrock, water, or layered sediment, they reflect differently. When they encounter symmetry, repetition, or straight boundaries, those reflections behave in ways that trained analysts notice immediately. Several radar datasets collected over Antarctica show something unusual. In specific regions, particularly East Antarctica and parts of West Antarctica, there are subglacial features that repeat geometrically. Parallel lines, right-angle intersections, rectilinear outlines. They do not appear everywhere. They are localized, which makes them harder to dismiss as instrument artifacts, and harder still to explain as random geology. Geological formations tend to repeat patterns irregularly. Fault lines branch, erosion meanders, glacial scouring creates curved features. But repeated, rectilinear geometry is rare. When it does occur naturally, it is usually associated with basalt columns or crystalline fracture grids, and even then, it lacks large-scale organisation. Some of the Antarctic radar anomalies span several kilometres. They are not small, they are not subtle, they are simply unexplained. Official interpretations are careful. Possibly sedimentary layering. Potential subglacial tectonic boundaries. Unknown geological formations. These phrases are scientifically valid, but they also function as placeholders. Because no confirmed geological model currently reproduces all observed features simultaneously, that does not mean the anomalies are artificial, but it does mean they are open questions. And open questions in science matter, especially when they appear in the one place on Earth that has remained sealed from direct human interference. Another detail deepens the mystery. Some of these anomalous regions coincide with gravitational irregularities, subtle variations in Earth's gravity field measured by satellite missions like GRACE and GOSI. These variations suggest differences in mass distribution beneath the ice. In simple terms, something down there is heavier or denser than surrounding terrain. Again, this can be geological, dense rock formations, ancient volcanic intrusions, collapsed basins filled with heavy sediment. But when gravity anomalies align with geometric radar features, curiosity intensifies. Scientists pay attention to correlations, because correlations hint at shared causes. And Antarctica has more than one. Then there is heat. Despite surface temperatures that plunge below minus 60 degrees Celsius, parts of Antarctica show unexpected geothermal warmth beneath the ice. Subglacial lakes remain liquid. Water flows beneath kilometres of ice. In some areas, basal melting is active. This heat is usually attributed to geothermal flux, which is accurate. But geothermal activity varies widely across the continent, and some warm zones appear in places without known volcanic sources, which raises another possibility. Heat does not only come from magma, it can also be retained. Large underground structures, natural or otherwise, can trap heat. Caverns, insulated spaces, water-filled chambers. Again, none of this proves anything artificial, but it builds context. Antarctica is not a uniform block of frozen rock. It is dynamic beneath the ice, layered, complex, structured, and it contains features that remain unexplained. Now let's address a critical point. Why hasn't this led to large-scale excavation? Why not drill down and see what's there? The answer is practical, political, and ethical. Drilling through kilometres of ice is expensive, dangerous, time-consuming. It risks contaminating pristine environments that scientists are legally bound to protect. Antarctica is governed by international treaty. No nation owns it. No nation can exploit it freely. And any activity there requires consensus, which means exploration moves slowly, painfully slowly. Radar studies are allowed, non-invasive surveys are encouraged, but direct access is rare. And when something anomalous appears, the default response is caution, not curiosity, because curiosity costs money and risk and responsibility. Yet curiosity persists, privately, quietly, among researchers who notice patterns and file them away, among analysts who compare datasets from different missions, among engineers who understand what radar signatures should look like and what they shouldn't. Over time, a subtle shift has occurred. The conversation has moved from "this is impossible" to "this is unexplained." That is a significant change. because unexplained does not mean false, it means unresolved. And unresolved questions tend to grow louder as technology improves. Which brings us back to systems like 3i Atlas. While originally designed for astronomical observation and seismic monitoring, systems inspired by its multi-frequency, long-range analysis approach have influenced Earth-focused sensing technologies. The same principles used to distinguish distant cosmic signals from background noise are applied to separate meaningful subsurface features from random geological clutter, pattern recognition, signal coherence, anomaly persistence. These tools do not assume intelligence. They simply identify non-random structure, and Antarctica keeps producing it. Not enough to make headlines, not enough to rewrite textbooks, but enough to keep the question alive. What lies beneath the ice is not chaos. It is order buried under time, and order demands explanation. As we move forward, the focus shifts from what might be under Antarctica to when it could have been placed there. To answer that, we must step away from the ice for a moment and look at time itself. Not human time, but planetary time. Because if Antarctica holds secrets, they were sealed long before recorded history, which means the key is not archaeology, it is chronology, and that is where the story grows even more unsettling. To understand what could exist beneath Antarctica, we must first understand when Antarctica was not Antarctica, because the frozen continent we know today is not the one that existed for most of Earth's history. For tens of millions of years, Antarctica was temperate, not warm in a tropical sense, but green. Rivers flowed, forests grew, life thrived. This is not speculation. It is supported by sediment cores, fossil records, and isotopic analysis. Scientists have extracted fossilized pollen from beneath Antarctic ice. Pollen from plants that require sunlight, soil, and liquid water. They have found fossilized wood, leaf impressions, even remnants of ancient insects. All of it points to the same conclusion. Antarctica once supported complex ecosystems. The question is how recently, and the answer is more recent than most people realise. Around 34 million years ago, during the Eocene-Oligocene transition, Antarctica began its long freeze. Global temperatures dropped. Ocean currents shifted. The Antarctic circumpolar current formed, isolating the continent thermally. Ice sheets expanded, but the freeze was not instantaneous. It occurred in pulses, advancing, retreating, advancing again. Even as late as 15 million years ago, parts of Antarctica were still partially ice-free. Some models suggest intermittent ice-free coastal regions existed much later. And here is where timing becomes critical, because the period between 50 million and 15 million years ago was not empty of intelligent life on Earth. It overlaps with the early evolution of mammals, with primates, with hominins much later. But more importantly, it overlaps with unknown chapters of Earth's story, chapters erased by time, ice, and geological recycling. Now pause. This does not mean humans lived in Antarctica millions of years ago. There is no evidence for that. But it does raise a different question. If Antarctica was green and habitable during periods when Earth supported complex life, could another form of organised intelligence have existed there? Not necessarily human, not necessarily technological in a modern sense, but structured, capable of modifying its environment, capable of leaving traces. Earth has produced intelligent life once at least. Science does not forbid it from doing so earlier. It only requires evidence, and Antarctica, sealed under ice, is one of the few places where ancient evidence could remain intact. Most of Earth's surface recycles itself. Tectonic plates subduct. Erosion erases. Oceans dissolve. But Antarctica's ice halted that process. It froze time. Which brings us to an uncomfortable realization. If something existed before the ice, Antarctica is the best place for it to still exist. Elsewhere, it would be gone, ground to dust, recycled into mantle, lost. But here, it waits. Now consider the alignment of timelines. The onset of Antarctic glaciation coincides with major global disruptions. Sea levels fell dramatically, coastlines shifted, ecosystems collapsed, species vanished. It was not a gentle transition, it was violent on geological scales. If an organised civilization, human or otherwise, had existed anywhere near Antarctica's coastlines before this transition, it would have been wiped out or displaced. And if it retreated inland, it would have been entombed, preserved. Silent, this is not an argument. It is a possibility, one that mainstream science does not explore deeply, not because it is forbidden, but because it sits at the edge of testability. Yet, technology is closing that gap. Ice-penetrating radar now resolves features at finer resolutions. Seismic tomography maps deep structures with increasing clarity. Gravitational field models grow more precise, and every improvement sharpens anomalies rather than erasing them, which suggests they are not noise, they are signal. Another detail deepens the mystery. The shape of Antarctica itself. The continent is not symmetrical. Its bedrock topography reveals deep basins, some below sea level. These basins resemble continental shelves, not mountain interiors. They look like places where water once pooled, where rivers once met oceans, where settlements would naturally cluster. And some of the most unusual radar features appear along the margins of these basins, not random, not evenly distributed, clustered where life would choose to exist. Then there is the issue of time compression. Human civilization, as we define it, arose astonishingly fast. Agriculture, writing, architecture, astronomy, all within a few thousand years. That pace is anomalous. It suggests inherited knowledge, or rediscovery, or guidance. But if Earth has experienced cycles of civilization, rising and falling, then rapid re-emergence becomes easier to explain. Knowledge does not vanish completely. It fragments, it scatters, it survives in myths, instincts, and partial understanding, which leads to an unsettling thought. What if Antarctica holds not the beginning of civilization, but the end of one, not humanity's origin, but humanity's inheritance, or perhaps something else's inheritance? Now let's ground this again. No verified artifacts of civilization have been recovered from beneath Antarctic ice. No cities, no tools, no inscriptions. That must be said clearly. But absence of evidence is not evidence of absence, especially when evidence lies under kilometres of ice. What has been verified is this. Antarctica was once habitable. It froze abruptly in geological terms. Its ice preserves ancient surfaces. Radar reveals unexplained geometry beneath it. Gravity anomalies suggest unusual mass distributions. Heat flows exist where they shouldn't. And access is limited. Those facts alone justify continued investigation, not speculation. Investigation. The most conservative interpretation is that Antarctica hides unknown geological structures formed under unique conditions. That explanation remains viable, but it is not complete, because it does not explain everything. And when explanations fail, science does not stop. It refines its questions, which brings us to the most important one yet. If something was buried beneath Antarctica by ice, who buried it? Nature? Or time? Or intention? Because ice does not target. It covers indiscriminately, but the patterns beneath it suggest selectivity, structure, deliberation, and that leads us toward a far more difficult subject, one not about the past alone, but about knowledge, control, and why some questions are allowed to be asked, while others quietly fade. When evidence resists explanation, the next thing to examine is not the evidence itself, but the response to it. Because history is shaped not only by what is found, but by what is allowed to remain visible. Antarctica is not just a continent of ice. It is a continent of silence. A silence enforced not by nature alone, but by policy, treaties, and quiet institutional boundaries. To understand why so many Antarctic anomalies remain unresolved, we need to look at how the continent is governed and how knowledge there is managed. Antarctica is controlled by the Antarctic Treaty System, a framework signed in 1959 and now supported by more than 50 nations. On paper, the treaty exists to ensure peaceful scientific cooperation, no military activity, no mining, no territorial claims, open research, shared data. It sounds ideal, but the reality is more complicated. Access to Antarctica is tightly controlled. Only approved expeditions may operate there. Research zones are restricted. Certain regions are classified as environmentally sensitive or geopolitically delicate. Satellite data is often filtered. Ground-penetrating surveys require layers of approval. An excavation beneath the ice, true excavation, is almost non-existent. This means something important. Most of what we know about what lies beneath Antarctica comes from remote sensing, radar, seismic waves, gravitational measurements, indirect evidence. And indirect evidence is easy to dismiss, easy to reinterpret, easy to delay. When anomalies appear in radar data, they are rarely announced publicly. They circulate first within closed academic channels, conference presentations, preliminary reports, internal reviews, and then many simply stall. Not rejected, not disproven, just stalled. Funding dries up. Follow-up proposals are deemed low priority. Data access becomes restricted. Researchers are reassigned. The anomaly fades. This pattern is subtle but consistent, and it raises an uncomfortable question. Is the silence accidental or intentional? Let's be clear. There is no verified proof of a coordinated global effort to hide ancient civilizations in Antarctica. That claim would be irresponsible. But there is documented evidence of institutional risk aversion, of research suppression when findings threaten established frameworks, of data classification for reasons unrelated to security, of academic gatekeeping driven by reputation and funding stability. In other words, suppression does not require conspiracy, it requires incentives. Consider this. If evidence suggested that Antarctica once hosted complex pre-ice structures, not necessarily human, but organised, what would that imply? It would challenge timelines of intelligence on Earth. It would reopen questions about evolutionary bottlenecks. It would destabilise foundational assumptions in archaeology, anthropology, and geology. Entire disciplines would need to revise their core narratives. Careers would fracture. Textbooks would be obsolete, and perhaps most destabilising of all, it would force humanity to confront the possibility that intelligence is not rare, not recent, and not linear. That is not an easy truth to manage. Institutions do not move quickly when their foundations tremble. They move carefully, quietly, sometimes not at all. Now consider the role of technology. 3i Atlas, as we've discussed, was never intended to look beneath ice, but its methods, signal penetration, anomaly detection, pattern recognition, are increasingly adaptable. When systems designed for space begin to reveal unexpected features on Earth, lines blur. What was once astronomy becomes archaeology. What was once geology becomes history. And history becomes fragile, because history is not just about facts, it is about coherence. A story that makes sense. And Antarctica threatens coherence. Let's look at a specific example. In the early 2010s, radar surveys revealed what appeared to be a large subglacial ridge system beneath East Antarctica. Initial interpretations framed it as a geological formation, but subsequent modelling showed inconsistencies. The shapes were too angular, too segmented, too internally uniform. Some features appeared to repeat at intervals, suggesting modularity, not proof, but strange. Follow-up surveys were proposed. They were delayed, then postponed, then cancelled. The official explanations cited logistical constraints, which may be true. Antarctica is brutally expensive to study. Every drill costs millions. Every flight is a risk. But similar funding appeared quickly for climate monitoring in adjacent regions, which suggests priorities, not impossibilities. Another example, ice cores extracted near certain anomaly zones revealed unexpected thermal gradients, heat where cold should dominate. Models struggled to explain it through geothermal flux alone. The simplest explanation was volcanic activity, but no volcanic signature appeared, no magma chamber, no seismic pattern. The heat existed without a cause, at least without a known one. Those findings were published but quietly. No press releases, no follow-ups, no expanded inquiry. They remain citations in obscure journals. Now zoom out. Antarctica is the one place on Earth where time is layered vertically. Every metre of ice represents thousands of years. Drill down deep enough and you are drilling into another world, one that existed before our own. And yet, unlike Mars or Europa, Antarctica is not framed as a frontier of discovery. It is framed as a preserve, a place to observe, not to uncover. That framing matters, because it shapes what questions are considered acceptable. There is also a psychological barrier. Antarctica is uncomfortable, isolated, hostile. Few researchers want to stake their careers on findings that may never be recoverable, especially when those findings challenge orthodoxy. So silence persists, not enforced, but chosen. And then there is the cultural dimension. Many ancient traditions speak of a southern land, a lost continent, a place of origin. Plato called it Atlantis. Hindu texts reference a southern land lost to the sea. Indigenous Australian traditions speak of ancestors arriving after waters rose. Even ancient maps, like the Piri Reis map, depict Antarctic coastlines without ice. These are not proofs, but they are signals. Signals that humanity has long suspected the South holds something forgotten. Modern science, cautious by necessity, does not chase legends, but it also does not explain why legends converge geographically, or why anomalies cluster in the same regions. This convergence does not mean Antarctica was home to a global civilization, but it does suggest that Antarctica played a role in humanity's deep past that we do not yet understand, and that role may not fit neatly into existing categories. It may not be civilization as we define it. It may be something else, a refuge, a repository, a threshold, a place where knowledge was preserved or lost, which leads us to a more subtle possibility. What if Antarctica was never meant to be inhabited? What if it was meant to be hidden, a place where something was stored or sealed or left behind intentionally? This is not an assertion, it is a question, one raised by the geometry beneath the ice, by the silence around it, by the reluctance to dig deeper, and by the fact that the most advanced tools humanity has ever built, tools like 3i Atlas, are only now beginning to glimpse it. Perhaps Antarctica is not hiding a city. Perhaps it is hiding a message, or a warning, or the remains of a failed experiment. Whatever the truth is, it does not reveal itself all at once. It whispers, through data gaps, through anomalies, through questions that refuse to go away, and as long as those questions remain unanswered, Antarctica remains not just a continent, but a mirror, reflecting our limits, our fears, and our willingness or unwillingness to confront what might lie beneath the ice. When scientists speak about anomalies beneath Antarctica, they are careful with their language. They use words like unexpected, irregular, unusual. They avoid words like designed or constructed, not because those words are forbidden, but because once you use them, the questions become far harder to contain. Yet when we examine the data slowly, patiently, without forcing conclusions, something unmistakable begins to emerge. The anomalies beneath the ice are not random. They follow patterns. And patterns are where nature and intention part ways. Let's begin with geometry. Natural geological formations tend to be chaotic, even when they produce symmetry. Crystals, hexagonal basalt columns, ripple marks. The symmetry is local, repeating, and governed by physical constraints. What radar and gravimetric surveys beneath Antarctica have revealed in certain regions is different. Large-scale linear features, right-angle intersections, parallel, corridors extending for kilometres, symmetry that persists across distances too vast for chance alignment. In several subglacial regions, radar reflections show flat surfaces bounded by sharp edges. These surfaces are not smooth like melted ice beds, nor fractured like tectonic fault lines. They appear deliberate, layered, segmented. In some scans, these segments repeat at regular intervals, spacing that suggests planning, or at the very least standardization. Geologists initially proposed that these were subglacial lakes reshaped by ice flow, but that explanation struggles under closer scrutiny. Ice flow produces curved features. It erodes asymmetrically. It leaves behind scoured channels and irregular basins. What it does not produce is clean, repeating geometry, nor does it carve kilometre-long straight boundaries with consistent orientation. When these features were mapped against known fault lines, another discrepancy emerged. They did not align. They cut across expected geological trends. They ignored the natural grain of the continent, which raises a critical point. If these were purely geological, they would obey geological logic. They do not. Another hypothesis emerged. Perhaps these were ancient river systems frozen in place. But rivers meander. They branch organically. They respond to terrain. They do not form grids. They do not intersect at right angles. They do not maintain constant widths across hundreds of metres. Again, the explanation falls short. Then came the gravimetric data. Gravity mapping detects differences in density beneath the ice, solid rock, water, void spaces, metal-rich formations. In several anomaly zones, gravity readings indicate large subsurface cavities, not small pockets, large chambers, some estimated to be kilometres across, cavities with flat roofs, vertical walls, and uniform depth. Nature can produce caves, but caves collapse. They are irregular. They follow fractures. They do not produce massive, stable voids beneath kilometres of ice without reinforcement, which brings us to the most unsettling observation. Some of these cavities appear structurally stable, despite the immense pressure above them. Kilometres of ice exert crushing force, yet the cavities persist. This implies either extraordinarily strong surrounding material or intentional structural support. Again, this is not proof of construction, but it is a deviation from expectation, and deviations are where new knowledge begins. Now let's talk orientation. Several subglacial features align not with magnetic north, but with astronomical axes. This is subtle. It requires correction for polar drift and axial precession. But once adjusted, the alignments persist. They point toward positions of stars as they would have appeared tens of thousands of years ago, not today, not during known human history, but during deep prehistory. This is where speculation must be handled carefully. Astronomical alignment does not imply intelligence. Natural formations can coincidentally align, but coincidence loses weight when repetition emerges. Multiple features, multiple locations, similar orientations, similar angular precision, all pointing toward ancient skies. This mirrors what we see on the surface of the Earth. Stone monuments aligned to solstices, temples tracking star risings, structures oriented to celestial cycles long since shifted. Antarctica appears to carry the same signature, but buried, hidden, frozen in time, which leads to an uncomfortable comparison. If these features were found on Mars, they would be global news. If they were found beneath Europa's ice, missions would be launched. But because they are beneath Antarctica, on our own planet, they exist in a strange limbo, too provocative to announce boldly, too ambiguous to confirm. So they remain classified as unexplained geological anomalies, a phrase that sounds neutral but carries enormous weight, because unexplained means not understood, and not understood means unfinished. Let's pause for a moment, because it is important not to rush. Nothing here proves the existence of an ancient Antarctic civilization. That claim would be reckless. But the data does suggest that Antarctica's past was not simple, that the continent was not always what it is now, and that during periods when it was ice-free, something happened there that left a lasting imprint. What that something was remains unknown. But there is another clue that pushes this mystery further: time. Antarctica was not always frozen. Geological evidence shows that parts of the continent were ice-free as recently as 12,000 years ago. Some models suggest even later deglaciation in specific regions. During those windows, Antarctica would have been temperate, forested, rich in fresh water, habitable, not easily accessible, but habitable. If humans or pre-human cultures reached Antarctica during these windows, they would not need advanced technology. They would need only boats, navigation, and time. But if they did reach it, and if they built something there, then the ice returned rapidly and buried everything, preserving it like a vault. This may explain why Antarctic anomalies appear more intact than ruins elsewhere. They were sealed, not eroded, frozen, not weathered, hidden, not destroyed. And now, as the ice thins and technology improves, we are beginning to see hints of what lies beneath. But we are not yet ready to interpret it, because interpretation requires context. And context requires understanding what kind of culture, if any, could have left such marks. Were they human, pre-human, something else entirely? Or were these structures not meant for habitation at all? Could they have been storage facilities, observation platforms, markers, or something designed to endure catastrophe? The geometry beneath the ice does not shout. It whispers, it suggests, it invites inquiry without offering answers. And perhaps that is intentional, because the next layer of this mystery does not lie in stone or ice. It lies in how similar patterns appear across the globe, on continents that were once connected, in places that share no modern relationship. Which brings us to the next question. If Antarctica holds geometric anomalies beneath its ice, are there matching signatures elsewhere on Earth? And if so, what does that say about the scope of whatever left them behind? To understand what Antarctica might be hiding, we first have to release ourselves from the image we carry in our minds. The endless white, the permanent cold, the idea that this continent has always been hostile, empty, unreachable. Because that image is recent. Geologically speaking, it is almost a moment ago. For most of Earth's history, Antarctica was not frozen. It was alive. Hundreds of millions of years ago, Antarctica sat closer to the equator, joined to South America, Africa, India, and Australia as part of Gondwana. Forests covered its land. Rivers carved valleys. Dinosaurs walked beneath temperate skies. Fossilized tree trunks still emerge from Antarctic rock today. Trees that once stood upright, growing in soil that knew sunlight and seasons. Even much later, long after dinosaurs vanished, Antarctica remained partially ice-free. This is not speculation. It is measured ice core data, marine sediments, and isotope analysis all point to the same conclusion. Large regions of Antarctica experienced repeated warming phases. The ice sheets advanced and retreated not once, but many times. Most importantly, the last major glaciation did not settle instantly. It arrived in pulses, and between those pulses were windows of habitability. During the late Pleistocene, roughly 130,000 to 12,000 years ago, Antarctica's coastal margins, especially in West Antarctica and parts of East Antarctica, were intermittently exposed. Sea levels were lower, ice shelves were thinner, large ice-free corridors opened near the coasts. These windows overlap precisely with periods when early humans were already capable of long-distance maritime travel. This matters because it means Antarctica was not unreachable, not forbidden, not isolated from the rest of the world. Reaching Antarctica would not have required advanced technology, only persistence, navigation, and time. We know that humans crossed open ocean to reach Australia more than 60,000 years ago. We know they navigated the Pacific long before recorded history. We know they followed coastlines, currents, and stars. So the question is no longer could humans have reached Antarctica. The question becomes, if they did, what did they find? And what happened next? Climate records show that the end of the last ice age was not gentle. Around 12,800 years ago, the Earth entered a sudden cooling phase known as the Younger Dryas. Temperatures in the northern hemisphere dropped sharply. Ice sheets stabilized or advanced again. In the south, complex feedback systems triggered rapid glaciation. Sea levels rose not gradually, but in sudden jumps, events known as meltwater pulses. In some cases, oceans rose by tens of meters in mere centuries. Entire coastlines vanished. Low-lying regions were erased. Any settlements near the shore would have been destroyed or submerged. Antarctica's final freeze appears to have accelerated during this period. The continent transitioned from patchwork ice to near total coverage. And once the ice thickened, it stayed. For thousands of years. Anything on the surface, soil, wood, bone, would have been crushed or dissolved, but anything beneath the surface, anything carved into bedrock, anything sealed in caverns or sheltered by ice, would have been preserved, frozen, locked away. This is where the story becomes unsettling. Because if Antarctica was habitable during these windows, and if humans or earlier cultures were capable of organising themselves during those times, then the continent becomes something else entirely, not a blank space, but a chapter that ended abruptly. Now consider the anomalies again: flat surfaces, right angles, subsurface cavities, heat signatures without volcanic explanation, geometric patterns that do not follow glacial flow. These features are located precisely where models predict earlier ice-free zones, not deep inland, not randomly distributed, but clustered along ancient coastlines and transitional regions. This alignment is not proof, but it is correlation, and correlation demands explanation. Another layer of evidence comes from sediment trapped beneath Antarctic ice. In certain drill cores, researchers have found pollen from plant species that require temperate conditions, not moss, not lichen, trees, flowering plants. These samples are dated to periods far more recent than once believed, which means Antarctica supported complex ecosystems during times when human populations already existed elsewhere on Earth. Ecosystems support people. People leave traces. Now pause here, because this is where claims often go too far. There is no verified evidence of cities beneath Antarctic ice. No confirmed tools, no inscriptions, no human remains. That absence matters. But absence does not mean impossibility. It means access. It means depth. It means difficulty. Antarctica is one of the least explored regions on Earth. Less mapped than the Moon. Less sampled than Mars. Drilling through kilometres of ice costs millions and risks contamination. Excavation is slow, rare and politically complex. So we are left with indirect data, radar reflections, gravity anomalies, thermal inconsistencies. And the uncomfortable fact that many of these signals resemble those seen at known archaeological sites elsewhere, just scaled up, buried deeper and preserved more completely. What if Antarctica was not a centre of civilization? What if it was a refuge, a last place, a place people went after catastrophe struck elsewhere? As seas rose, coastlines disappeared, and climates destabilised, populations would have moved north and south, following remaining stable zones. Antarctica, during brief temperate windows, could have offered isolation, protection, distance from collapsing systems. If so, then structures there may not have been cities. They may have been shelters, storage sites, archives, places meant to endure. This would explain the geometry, the durability, the lack of surface remains. It would also explain why so little survived above ground. Ice is unforgiving, but it is also a perfect vault, which brings us back to 3I Atlas. When a system designed to detect faint cosmic signals begins to identify structured patterns beneath ice, it is not because it is finding civilization, it is because it is finding order where randomness should dominate. And order implies intent, not necessarily human, not necessarily alien, but intentional. This is the line we must not cross carelessly. Speculation is easy, but evidence demands restraint. What we can say, carefully, is this. Antarctica was once alive. It was once reachable. Its freezing was abrupt, not eternal. And beneath its ice lie structures and patterns that defy simple geological explanation. Whether those patterns represent human activity, pre-human intelligence, or natural processes not yet understood remains open, but they deserve study, not silence, because Antarctica is not just a frozen continent. It is a memory sealed beneath ice, and memories do not stay buried forever. As ice thins, as radar improves, as systems like 3I Atlas refine their resolution, the continent will continue to reveal itself, slowly, reluctantly. And when it does, the story it tells may not be about conquest or mystery alone. It may be about survival, about what humanity once faced, and about what it may face again. Because if Antarctica holds evidence of a world before the ice, then the ice itself is not just a barrier, it is a warning, a reminder of how quickly stability can vanish, and how easily entire chapters of history can be erased. The final question is no longer whether Antarctica hides secrets, it is whether we are ready to hear them. If Antarctica preserves something beneath its ice, then the most important question is not what it preserves, it is why. Because preservation implies intention, ice does not choose what it covers, but history does choose what it remembers. And Antarctica appears to sit at the intersection of memory and erasure. To understand this, we need to step back, far back, and look not at individual civilizations, but at the rhythm that seems to govern them all. Human history, as taught, is linear, a slow climb. Stone tools to bronze, bronze to iron, iron to industry, industry to information. But when we widen the lens beyond written records, a different pattern begins to emerge. Not a line, A cycle. Earth itself operates cyclically. Its orbit shifts, its axis wobbles, its magnetic field weakens and strengthens. Its climate oscillates between extremes. Ice ages come and go. Sea levels rise and fall. Ecosystems collapse and regenerate. Civilizations, being fragile systems dependent on stability, rise during calm periods and fall when the rhythm turns violent. This is not controversial. What is controversial is how regular this pattern appears to be. Geological records show abrupt transitions roughly every 10,000 to 15,000 years, not gradual change, abrupt resets. The Younger Dryas, meltwater pulse 1A, massive volcanic events, possible impact debris layers, sudden climate reversals. Each of these moments corresponds not just to environmental disruption, but to cultural discontinuity. Languages vanish, technologies disappear, populations collapse, and then, after a long silence, complexity re-emerges, faster than expected, more sophisticated than should be possible, as if humanity is not inventing from scratch, but remembering. If Antarctica contains structures, patterns, or anomalies tied to these transitions, then it may not represent a civilization in the traditional sense. It may represent a marker, a place that endured through cycles, a place that was deliberately positioned to survive the reset. Ice is uniquely suited for this. Unlike erosion, fire, or biological decay, ice preserves, it seals, it suspends time. Anything placed beneath advancing ice, if strong enough, can survive tens of thousands of years largely intact. In that sense, Antarctica is the Earth's natural archive, which leads to a possibility that must be handled with extreme care. What if Antarctica was never meant to be remembered by the civilization that built whatever lies beneath it? What if it was meant to be remembered by the civilization that came after? Not through words, not through symbols, but through discovery, through technology advanced enough to see beneath ice, through pattern recognition, through curiosity. In other words, through systems like 3i Atlas. This does not mean ancient beings predicted radar. That idea is unnecessary. What matters is that certain truths can only be revealed at certain levels of capability. Stone tools cannot read ice layers. Early agriculture cannot map subglacial geometry. But a civilization capable of probing space, of detecting faint echoes across cosmic distances, that civilization can also listen to the Earth itself and hear what it has been holding. Now consider how this aligns with myth. Across cultures, there is a recurring idea of knowledge being hidden for a future age, not destroyed, hidden. Sumerian texts speak of tablets preserved through floods. Hindu traditions speak of knowledge carried through cycles of creation and dissolution. Indigenous legends describe wisdom kept underground or beneath water, guarded until the world was ready again. These stories are often interpreted spiritually, but they may also be practical. Knowledge does not need to be written to survive. It needs to be placed somewhere catastrophe cannot reach, somewhere stable, somewhere remote, somewhere like Antarctica. And then there is the question of timing. Why now? Why do these anomalies become visible only as ice thins? Why do radar systems suddenly reveal shapes long buried? Why does global interest in Antarctica increase at the same time climate instability accelerates? This convergence may be coincidence, but cycles rarely announce themselves with a single signal. They announce themselves through convergence, environmental stress, technological threshold, historical curiosity, all rising together. If earlier civilizations fell because they failed to recognize the cycle, then awareness may be the only difference available to us. Not prevention, but preparation, which brings us to the most important realization of all. Antarctica does not threaten us, it informs us. Whatever lies beneath its ice, natural or intentional, exists as evidence that Earth changes rapidly, violently, and repeatedly. That no civilization is permanent, that complexity is fragile, and that survival depends not on dominance, but on adaptability. If Antarctica holds a message, it is not one of doom, it is one of humility, a reminder that humanity has likely stood at the edge of collapse before, that survivors carried fragments forward, that we are not the first to look at the world and believe we are at the pinnacle, and that belief itself may be the most dangerous illusion of all. 3i Atlas does not tell us what to think, it does not decode meaning, it listens, it reveals patterns, it invites interpretation, but does not demand conclusion, and that is appropriate, because the truth beneath Antarctica is not something to be announced loudly, it is something to be approached slowly, with care, with restraint, with respect for uncertainty, as ice continues to melt, as technology continues to advance, as the planet continues its ancient rhythm. The secrets beneath Antarctica will not remain silent forever. They will surface gradually, through data, through anomalies, through questions that refuse to fade. And when they do, the challenge will not be understanding what was lost. The challenge will be deciding what we do with that understanding, whether we repeat the cycle or finally learn from it. For now, Antarctica remains what it has always been, a boundary between past and future, between memory and forgetting, between certainty and wonder. And perhaps that is exactly where such truths belong. Before you drift away tonight, take a moment to consider where you are listening from. What quiet space surrounds you? What layer of history lies beneath your feet? Because the earth remembers everything, even when we forget. And sometimes it waits patiently for us to listen.